In this video, we're going to carry on with our plastic housing design in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to carry on building our plastic housing, this time moving on to the top. But at the end of the last video, I left you with a question. I wanted to know what the difference was between using thicken on a drafted part versus creating a patch and using solid features such as the shell command. So the thing that we need to think about or we need to realize when we're dealing with these parts is that the draft angle is going to affect everything. So when we use something like thicken, that creates a thickened surface in the normal direction to the curvature. So this means that this upper face is no longer flat, it's going to be at 2 degrees. So these are the kinds of things that we need to consider when we're turning surfaces into solid bodies, especially when we're accounting for draft. For this example, I have to say, full disclosure, this is the third time filming this video. Now, I want to avoid getting too deep into surfacing topics because that's not the point of this series. But as I kept recording and as I kept building out the top of the housing, the design got more and more complex and there were just more issues with the surfacing tools in Fusion. So in this case, what I want to do is I want to simplify it a little bit. So we're going to do sort of a hybrid approach. We're going to use some surface techniques, then we're going to add more details once we get to the solid techniques. So the next step in this process is to begin building the upper section of the housing. Now, remember the original design has little tabs or little ears on the side of it, and those are used to be held down to something using zip ties. And I'm going to follow that same process. I want to use some way to hold this down with zip ties because it's intended to be on a motorcycle, and I'm not really going to bolt it down anywhere. However, when we look at this design from the top, we've got wires coming in from this side, potentially wires coming in here. We've got a USB-C and this quick connector, and we have this reset. We might want to incorporate a small hole, that way we can stick a screwdriver or something down there. So when we have all of those considered, we can't run a zip tie from the upper portion to the bottom portion lengthwise because it'll just get in the way of the wires. We can't run it from left to right directly in the middle because then we cover up the quick connector, the USB-C, and potentially the wires coming in here. So the only options we have are really to sort of split the difference. We're going to go from left to right, and we're going to go on either side of the microcontroller. So this will help us because, again, we're working with symmetry. We started this process by making sure that we were in the center of our coordinate system. So it makes it a little bit easier for us. We also broke up the bottom face into quadrants. So really we can focus on just modeling a corner. So the next step for me is going to be to use Extrude. I'm going to select this entire rim. I'm going to go to a right or a back view, and I want to bring this up. I want it to come up far enough that it goes completely over anything that I want to encompass. So 9 millimeters looks like enough. I want to go a bit further because I'm going to add extra and trim it away. Then we need to account for draft. Now, if we simply enter D and use our draft parameter, notice that it drafts it outward. Now, this is generally something we want to avoid because it will get stuck in a mold. We've already talked about the reasons why we need draft. So in this case, we have to use a minus sign before to ensure that it's drafting in the opposite direction. This is a new body, so we're going to say OK. And now we've got the upper section here. I can hide the bottom. I don't really need to see it. So just like we did on the bottom, we're going to create some arcs and create a swept surface. So I'm going to start a new sketch. I'm going to select my XZ plane. I'm going to use slice, and then I want to go to create, project include, and intersect. We should note that if you're using these tools all the time, you can pin them to your toolbar, your shortcuts, or you can even create a keyboard shortcut. If you pin to the shortcuts and you hit S on the keyboard, this is going to bring up your sketch shortcuts. This is contextual, so if you're working in the design workspace on solids, not in a sketch, you'll see a different list of tools. But here we could either search for intersect by simply hitting I, and you'll get everything that starts with an I, or you can again add it here, so that way it's a little bit easier to get to. So I'm going to go ahead and select those two on the side. I'm going to say OK, and I want to create an arc. So again, create, arc, 3-point arc. We're going to go from left to right, and then just create an arc here. I'm going to use horizontal, and we're going to create a horizontal constraint between these two sides. We want to make sure that this is coincident with our intersection. And then we can bring this down and put it at a rough location where we think it makes sense. So D on the keyboard or sketch dimension, we'll pick a position. In this case, looks like 12 millimeters, possibly 13 millimeters will be okay. And then just in the interest of fully defining everything, I'm going to give this a 300 millimeter radius. Remember the one on the bottom was like 650, I think, which means that it's less of a curve. It's got a larger radius value, which means it's closer to flat. So we're going to have a little bit more curvature on the top, and that's okay. It's going to change the way that this design looks. We're going to repeat the process. This time we're going to use the YZ plane. Once again, I like to slice. We're going to use intersect. And again, I have it on my shortcuts now. I can hit S, or you can go up to create, project, include, and intersect. We're going to make sure that we intersect with our arc as well as both sides here. I'm going to hit enter to OK that. Next, I'm going to create a 3-point arc. Once again, we're going to go from the left to the right, making sure we snap, and then we want to snap to this point here. You'll notice that this vertex is white, and that's because it didn't actually make a coincident constraint. So let's make sure that we do add that, and then make sure that these two are horizontal. It should over-define it, but just in case, we want to make sure that they're horizontal. Then I need to either give it a height from the origin or some other reference, or I can give it a radius value. So D on the keyboard, radius value, I'm going to say 200, a little bit less of an arc than it was coming in at, but you can see that it's different than the one that we've got going across the major surface. So we're going to say OK. And then we're going to use sweep, pick one of these as our sweep profile. We're using a single path, and we're going to create that surface. Note that we could extend this out. We could have created these curves to go a bit farther, but in the interest of symmetry, using those intersections really helps us. So now we have two surfaces here. In an ideal world, we should be able to stitch them together and just fillet the corner. It's the same thing we did on the bottom, but sometimes it's not going to work. So let's try that method first, and if it doesn't work, then we'll come back and we'll use some surfacing techniques. So again, I'm going to trim. I'm going to use this as my trim tool, get rid of this upper section here, right click and repeat that. This is my trim tool, and then I need to get rid of each of these little corners. You probably want to rotate this around because it does tend to have trouble when your selection is obscured by your trim tool. We're going to say OK. And now we're going to try to stitch these two together. What we should see is an entire green edge where they're going together. Now, once again, in an ideal world, we'll be able to fillet this. We're going to select this edge. I'm going to put 2 millimeters to start, and notice that it's giving me an issue. It doesn't like this. If I try to go down to 1 millimeter, you can see it's not working here either. So sometimes this tends to happen. Now, unfortunately, I don't know what is going to make or break it, but I'm going to manually go around and I'm going to try to select. Now, what ends up happening if we skip a selection, you can see that we can just go back, and what we're trying to do is create this entire chain. If I hit 1, notice that it's giving me an issue. It's saying that this edge right here is not working. If I deselect it, you can see that it's just telling me that the fillet's not working on some of these areas. So this is obviously problematic, and it's not going to be a good solution for us. It's going to take a lot of work to figure out why that fillet's not working. So I'm going to go back before the stitch. I'm going to get rid of these trims, just delete them. And now I'm going to create offsets. So while this is not an ideal method, it does give us a little bit more control. And what I'm going to do is I'm going to create an offset of this surface, and I need to go in the value that I want for my fillet radius or my blend. So you can see here that if I offset this and say -2, we want to go inward. This is going to go in 2, and we're going to use this to trim our upper surface. So we need to think about and plan out how far in we want that blend. For this example, I'm going to make it a bit more extreme. I'm going to go in 4, and then I'm going to repeat that offset. And I'm going to do it this time with this edge. I'm going to go -4, which is going to push us down. And then because this no longer intersects the entire edge, we can either use it as a split tool, and that split tool we can allow to extend out, or we can extend it manually and then trim. First, let's go ahead and try to use it as a split face or split body. So let's try split body first. Bodies to split will be this outside. The splitting tool will be this surface. We're going to allow it to extend, and we're going to say OK. Now if we take a look in our browser, this upper section here is no longer needed. It was able to split it even though that surface didn't actually touch it. Next, we want to do the same thing, splitting this upper surface that we want to keep with this. Now, again, we can use trim or split body. Either are going to be fine. For some reason, I find that split body tends to work a little bit better when you have surfaces that you need to extend. It saves you time of making extra features in your timeline. So we want to split this upper face. Our splitting tool is going to be this, and we're going to say OK. We don't have to extend it in this case. Just note that now we don't need this one. And this outside edge, we don't need that either. So what we're left with here is the upper surface and the border. And because we offset them, we have a really consistent distance between each edge. So all the ones that we aren't using, I'm going to select, I'm going to right click and remove. Remember, remove is going to put those features in my timeline. I can go back and bring them back at any point in time by just simply deleting or suppressing those. The next thing that we need to consider is the fact that we are working with symmetry. When we're working with symmetry, we really only need to focus on one corner of this. For right now, I'm going to hide the electronics housing. I'm going to create a new sketch on the top plane. And the reason that I want to do this is because now I can use my line tool and I can just draw the corner that I want. And the reason that this is helpful is because I don't have to do two trims or two splits with planes. And now I can simply just use this sketch. So we can use the trim or the split body. The trim tool is going to be our sketch, but we want to make sure that we hold down Control or Command and select both of those. And then we want to remove everything outside of it. We need to hide that sketch, and you can see now we're just left with this corner. So the way in which this would work ideally is if we were to either create some guides on the sides and use the patch tool, or we can simply loft between them. I'm going to try the loft approach using this upper edge. And you'll notice as soon as I went across these corners that it started to add additional profiles. And what that tells me is that inside of here, there is a small gap between those edges. And because of that, it makes it problematic for us to figure out what the tangency is along that curve. So one thing that we can do is we can try to turn on chain selection. And if we use chain selection, it's going to go around the entire thing. And this becomes problematic when we get to the bottom because you can see now it's trying to sort of combine the whole thing. So because of that, what I want to do is I'm going to clear both of these out, and I'm just going to go from one edge to the other, and I'm going to allow it to drive it based on curvature. So using that curvature continuity is going to allow us to take the shape at the top and blend it across and down to the bottom. I'm going to right click and repeat that, this time going from here to here. And once again, I'm going to use that same curvature continuity. So when we think about tangency versus curvature, really what we're talking about is just handling the direction of influence or also taking into account the radius that is at that intersection. So it helps us get a little bit smoother transition. So for example, profile 1, if we change it to tangent, you can see it's really only controlling the direction. And we have a tangency weight, which we can change if we want to, but we also have that for curvature. But when we change to curvature continuity, it's looking at the radius of curvature here, and it gives us a little bit better blend. Again, this is not intended to be a surfacing course, but that does just give us a different appearance, so I think it's important we understand it. Next, what I'm going to do is I'm going to try to create a loft to fill in this corner. You could also use patch, but I found for some reason in this geometry that patch is not working very well. So I'm going to grab these edges, top and bottom, I'm going to say curvature continuity. For the two sides, I'm going to try tangency first. I found that it's actually been problematic for these corners. I don't know why, but it doesn't seem to like this. So I'm going to leave these at connected, and I'm just going to say OK, allowing the curvature continuity of the top and the side to control it. That actually looks pretty good. That's going to be OK for us. Again, I can't stress enough, this is not a full best practices surfaces course. We're just looking to create this geometry. So while it might be less than ideal because we really didn't have full control in this corner, I think that everything looks pretty good. I'm looking at the reflections going across. You can use Control or I think Command and 4. You'll notice that as we zoom in, there is a slight line that happens here. And that is not ideal because we didn't control curvature across those edges. So if we wanted to spend more time, what we could do is instead of stitching these together, we could trim back a little bit and we can try to work in those corners. Some other options that we do have before we started doing our offsets and our splits and trims We could try to turn this into a solid body. And when we do the solid body conversion, sometimes it's a little bit more robust. But for this example, let's try to push forward and see if we can get a good solution. Next, I'm going to go to mirror. I want to mirror this entire body instead of faces. So select bodies, and then the mirror plane. We're going to go across that midplane. We could join them together here, but I'm going to leave that to another step. I'm going to repeat the mirror, both bodies here. The mirror plane is going to be our XZ plane. And again, we're going to use new body. And the reason we're doing that is because we're actually going to stitch all of them together. So I'm going to select the bottom and then the 4 quadrants on top. When I do that, you'll notice this top face doesn't have any divisions on it. It was able to patch it back to that original clean surface. So that's pretty helpful for us. And now we have a solid body. So at this stage, there are a couple things that we could do. We can split this up into a top and bottom and continue to work with it. Or we can go forward and we can make those recesses, the ones that we need for our design. So what I want to do is I want to make those recesses, but let's do a quick save just in case we lose anything. I'm going to bring back my electronics design. I'm going to create a new sketch, and I want to make sure that it's on the XZ plane. And now I'm going to slice through. You can see we've got solids here. These are all the things that we need to be aware of. Remember that we have those transistors, and those are going to be driving our height a little bit. But again, in reality, I was actually able to push them down pretty close to the board. So this USB connector is likely the highest thing that we need to worry about. So what I want to do is I'm going to create a line where I want my zip tie to rest. So I'm going to just draw a horizontal line. I'm going to use D on the keyboard to add a dimension. I'm going to make sure it's at least 5 millimeters wide, not really a big concern here. Then I want to give it a dimension to position its height, let's say 12 millimeters. And then I'm going to position it horizontally. I just want to fully define its location. I'm going to say 15. And the next thing I want to do is I need to create a cut, and we need to decide, are we going to do fillets on the sharp corners, or are we going to try to do some surfacing tools to blend it together? Now, I mentioned that this is the 3rd time I'm filming this, and what I found is that Fusion was having some difficulty when I was trying to make those smooth spline transitions and blends. So for this example, what I'm actually going to do is I'm just going to take lines up at an angle, and I'm going to create a sort of this cut. This top edge is parallel with this bottom. Doesn't really matter, but I want to control these angles that I'm coming away. So I'm going to use D on the keyboard, and I'm going to set this at 135 degrees. And on this other one here, because we're tapering away, because this face is dropping down, I could use the same angle or I could make it larger. It's really not going to matter. It's more of an aesthetic decision at this point. And once we have that, we can simply go to our solid tools and we can extrude cut it through the housing. So I'm going to set this to symmetric. We can set it through all. And we want to make sure that the objects that we're cutting are only the solid body for the housing. Now that we've cut all the way through, let's make sure that our objects to cut is just the plastic housing, and we're going to say OK. Next, we're going to try to add some fillets here. So I'm going to use my fillet tool, and I'm going to begin adding fillets here, remembering that if we're going to create a shell or a thicken, that we need to account for the radius value. 2 millimeters is going to be the thickness of our housing. So I want to make sure that this is at least larger than that. So I'm going to say 3, OK, and then I'm going to repeat that and do it on the outside. Note that we could add additional fillets inside of the fillet dialog box, but sometimes it's better for us to come out and do them after the fact. So here I'm going to say OK. Remember that we can use things like curvature continuity. And when we're crossing over a blend like this, curvature continuity is probably going to be a better option. But you can see here that it is causing some issues in those corners. If I set this back to tangency, you can see that it actually looks a bit better. So these are the kinds of things that we want to just sort of be mindful of and investigate while we're creating this geometry. So that looks pretty good. Now we have to figure out how to get it to the other side. And because we are working in symmetry, we can split this body up in half. So this is the body to split. The splitting tool is going to be our mid plane. I'm going to hold down the left mouse button until I find that YZ plane. You can see that it splits it right there. It's going to give us an additional body. This body we don't need, so I'm going to remove it. And then I'm just going to mirror this entire body. So create, mirror, make sure we're mirroring bodies, not components. The mirror plane can be that inside face, and we can join it together. We need to be careful when we join it together to ensure that we're not accidentally grabbing additional bodies. Everything else was hidden, so it won't automatically do that, but just note that we do need to be careful. So now we've got the solid portion of our housing. So you can see here, if I use Control and 4, I can hide the edges. We've got the little areas for the zip ties to go through. We have a pretty smooth result. If I go back to the top level of my design and I right click on my plastic housing and I change the opacity to something like 20%, you can see here that we can rotate around, we can investigate where our geometry is, and now we can make openings for things like this quick connector. We can make a drop, a cut, or a recess for the USB. And these are all things that we want to make sure we incorporate in the solid version right now before we really get carried away and start shelling it and trying to add internal features. So I'm going to reset the opacity. So we're going to go back to opacity control, set it to 100. Go back to home view, Control and 6 to bring those edges back, or visual style, shaded with visible edges. And now we can see the design. And I think at this point it actually looks pretty good. We need to do some work to split it apart, but we want to make sure that we account for at least that USB-C connector before we do. But at this part, let's go ahead and make sure that we save it. We don't want to lose any of our work. If you have any questions, please let me know either through email or comments on the video. And as always, thanks for watching, and we'll see you in the next one.